But what we're going to do is, rather than kind of using this complicated example with lots of things going on, we're going to build up our own little game, one element at a time, I think, and just use that as a way of moving into things. So the way we can do that is up here to grab this and go backwards. And I'm going to use the empty world template because I don't want a bunch of other scripts and behaviors in there. And so we're going to use this empty one to build some gameplay in. First of all, I'm going to save. What should we call this? Twitch tutorial game. And we'll save it. So we can see what's in the game right now. We've got some spawn points. What I was thinking about doing is totally stealing Ashley's turtles and turtle racing game idea and just doing that, making a really straightforward game where we're going to just guess which turtle's going to cross the finish line first. Let's get the speedy turtle. I can't remember any of the turtles' names, but the first thing you'll notice is we don't really have a standard like manipulator versus other game engines that you might have used. This one is designed to be a bit more easy to use, and we will also we'll let you switch to an advanced mode where you'll be able to, use a more normal, I was going to say natural, but there isn't really anything natural about it, a more normal set of axes and things to move things around that you might be used to if you want that. So this control has many things. It has this, which keeps the turtle attached to the ground correctly. This moves your turtle up and down. So if he's off the ground, I can click this and it will drop him straight back down. Can scale the turtle up and down. We can rotate the turtle on different axes. In this case, you'll see that the axes are local to the turtle. If I press R, I can switch to a world space rotation. So now I've got my turtle in the position I want. I can rotate them round and around and around the up axis, for example. You can also do the same thing with translation. Yeah, so you can wiggle the turtle around, and also you can press T, and then you're wiggling the turtle around in its local space. So up is now this way, and kind of forwards and backwards, left and right is now here. So he's moving along a plane that's kind of indicated by that orange color there. And then if we do this, this is again stays in world space because it doesn't make much sense otherwise. And so we want some other turtles, and thankfully Ashley has given us plenty of turtles. We've got a pink turtle. That is a cute turtle. We've got this double turtle as well. Let's build a finishing line. Grab it, move it about, and then we want to rotate it around, and we can push it into the ground. So it's just sticking out. We probably want to make it a bit bigger as well. So we're just going to fire our turtles across there to start off with. Yeah, and so we have a starting line and a finishing line. And the way I was thinking about making the game work is essentially when I press play, they go and we'll manually watch who crosses the finish line. And I'm also going to show you how to make it networked as well, because I think that will be fun, in particular to get a few people in. So what we're going to do first of all is just make our turtles move at all, because right now we press play and nothing happens. So we need a script, and I'm going to make a totally new script. Move forward. It's published. It's usable by other people. You can say whether you want your stuff to be used by other people or not. And it's remixable. That means people can save a new copy of it and start modifying it themselves. So we're all about sharing and letting other community members use our work, essentially. In the future, we'll be able to package these up and sell them as assets to other people as well. And you'll notice up here, there was a little red dot. When you have stuff that's unsaved, you'll have a little red dot up here. But this little red dot also means that you can save things now as well. Press Ctrl S there, and it'll save everything, including the scripts. So we're going to move forwards, and to do that, we're going to need to know how fast to go, probably. So we have this sum number property up here, and if we look across here, we can see our script, and we can see sum number is 42, and we can change that, get 48, for example. And that doesn't change the default. This is just a default value, whereas each instance of the script on something in the world can have its own value for a property. So this is a way in the editor or a way of showing the editor some values that players can set up. And there's a whole bunch of different things you can put in there. And you can find out what those are by heading across to our docs. And they're on docs.bigbang.com. And there's a basic introduction to scripting with some examples. And amazingly, I have already done some of this before. I was not thinking about this at all, honest. But here's the move forward script in a lot more detail probably than we're going to actually do it. But here's every single kind of like property of properties, things that you can make. And there's quite a lot. So back to our script that we're doing. We're going to make this a speed. So I can just change the name to speed and fix the formatting because I'm fussy about that. And we can see this is straight away changed to a speed of 42. Is that fast or slow? I don't know, but we can find out. So TypeScript has this idea of decorators. The nice thing about TypeScript and using this is we get full autocomplete kind of help with our text. You can see I've typed description and it's telling me that it wants a string, which kind of makes sense. And again, it will tell you there as well. And then another decorator we can use is a number range, which kind of does what you'd think it would do. It can go between 0 and maybe 500. When you mouse over the property itself, you can see that description text so people can understand what it is that they're trying to set up. If it's something maybe less obvious than speed. And the number range then gives us this nice slidable bar that lets us manually fiddle with how fast things are going. In here, we have two functions already defined, or methods, because it's on a class. We have start and we have tick. And these are script callbacks, and they're how the engine tells your scripts that things are happening. So start is called a bunch of different times, but most commonly when an entity has been created and the script has been added to it, it'll have start called, and that's where you can set up extra data that you couldn't set up in properties outside of it. So you can default initialize property values. If you need to do something more complicated, you can do it in start. It's kind of like a constructor, but not the constructor if you're used to programming. And tick is called every single frame. Every time we want to update the simulation, the state of the world that has everything in it, we'll do that in tick. But right now we don't need start because we don't have anything to initialize, so we can delete it. We're just going to use tick. And what we want to do is move our turtle forwards in the direction that it is currently facing. So what direction is forwards? And that is actually something that's quite easy to find out because we have this idea or this concept of a transform, which is common to games in general. Transform defines essentially where that entity is in the world. It has its position, it has how it's rotated, and it has how it's scaled, all stored in there. So transform, position, rotation, and scale. So this blue line is the Z-axis, green line is the Y-axis or up axis, and this red line is the left axis. So we want to get the forward. And the nice thing about a scripting system is it gives you easy access to things that you might want access to. So this .entity is the entity the script is on. And we have a ton of different things and information you can get about this entity. And all of this actually has full docs in it. So I can go in here and you can look at the local transform. So lots of information about that, what that does. But we want the world transform because we want to know which way forward is in the world, and we want to get forward. So we'll call this method on the transform and it will tell us what direction forward is facing in. And then the next thing we want to do is move forwards in that direction. As I said, tick is called every single time we're going to update the simulation, but we don't know how much time has occurred since the last tick has happened. But thankfully the engine tells us that as well. So time since last tick. So we're going to get this .game. This is the game that we're running in. And we're going to get frame delta time. So time since last tick. So that's the amount of time that has gone by since the last tick in seconds. We have a speed, which is in units per second. Like the unit of one piece of distance is the size of one voxel. at a scale of 1. So the distance equals the speed that we want to go multiplied by the amount of time. So our distance to move is our speed multiplied by the time since the last tick happened. How do we move ourselves that distance? Well, we know what direction we want to go in, and we know that our direction vector is 1 unit long. And so if we multiply our direction vector by our distance, that's going to scale that direction vector up to be the same length as our distance. And that's really handy because that's how far we have to move in the direction we want to go in, which is basically our answer. So we can do exactly like that. So movement, we could be even more excruciatingly clear. Movement this frame is our forward vector multiplied by scalar. A scalar means just a number. And this is going to multiply each component of this vector by the number that we put in. So it will scale it up by that amount. The thing to be really, really aware of with TypeScript in this case is this vector here is going to change when we do this multiplication. So we've got this vector out and this multiplication is being done to this variable. And even though we've stored it in a new thing called movement this frame, these two variables are pointing at the same thing, the same vector 3. And so when you change one, you change the other. If we wanted to avoid doing that and to keep forward as it was, we can call clone, which will give us a new vector with the same values. And now they will be different to one another. So I'm going to leave that in there. Although we don't need to reuse this value, it's kind of confusing if you come to it the first time and think that you might be able to use forward later. So if you want to base things off this script, you'll be able to know and be safe to do that and reuse forward for something later along the line. It's also something you'll run into a bunch when you're programming as well. We know how much time has elapsed. We know how far we need to move based on our speed. And we know what that actually is as a movement in world space. So we just need to apply that to our entity. And that's easy. We're revisiting things that we've touched before. So getting the world transform out. And you can see down here we have the position, rotation, and scale. So we want to get our position and we want to add the movement this frame to our position. And that's it. That's the whole thing done. We're just moving forwards at a set speed. And we've added it to this turtle. So we can hit play and the turtle will trundle forwards. And we can adjust the speed and they'll run forwards indefinitely. And then we can stop the game to reset everything back to the start. And we did that, and we didn't even have to save it, is an important thing. Just editing the script, recompiles it, and that action takes effect immediately. So we're moving forwards, but only one of our turtles is moving forwards. So let's save this script so we don't lose our work to date. Yeah, and we've got this guy, we've got this guy, this guy, this guy. So I've multiply selected them. All three of these I'm going to add the same script to. I want mine. We've got the turtle on them. So if we run the game now, all of the turtles move forwards and one of them moves forwards faster than the other and they sort of overlap each other. So we have our race. Our race is happening. It would kind of be nice if we didn't have just a fixed speed. Like we could say, okay, well, I know from Ashley's game, this turtle should be the fastest. This basic turtle is, I don't know, really slow. This turtle loves 42 and this turtle is ever so slightly slower. And if we go in and just like line them up properly as well, we could say, okay, well, our game is going to be like this, and we can save our game just for the sake of making sure we don't lose our work. We can have our game run like this, which is fine. There's a winner. We can see that there's a winner. There's a second place, a third place, and a fourth place. But we also know precisely which one is going to win. So that's no good. So we're going to need to change our script to make that not happen. What we could do is have a base speed. So how fast should the turtle go as a starting point, and then have a spread. So we're going to put start in there because we're going to do some extra calculation. And as we said, start is run when the script is very first added on to our entity. So we'll add that on and we'll save it. And we'll keep this called speed. And then I'm going to have one called spread. But these are like our base speed. So let's go back up. I can use the engine itself to just rename this to base speed. And it'll automatically fix the entire script for me. And we can see that base speed has been changed in there now. So we've got the base speed and the spread. And so what we want to do is work out how much spread to apply to our base speed. What I want to do is have the spread either side of the base speed. So you can go like a maximum of 5 below and a maximum of 5 above. And to do that, what we want to do is essentially work out a value which is twice the spread and then take away the initial value of spread from it. So this is our spread now, which is 5. And this is 10, which is double it. And we're going to generate a number for our spread between 0 down here and 10 up here. And then we're going to subtract 5 away from it. And you can kind of see what will happen if it comes out as 10, then it will become 5. And if it comes out as 5, then it will be no spread. And then if it comes out as 0, then it will be minus 5. And so that transforms our number range from 0 to 5 to minus 5 to plus 5, which is what we want. Spread amount. So we're going to use math.random, which is one of the inbuilt browser functions. And it returns a pseudo-random number between 0 and 1. I'm going to multiply that by our spread. So that gives us a number between 0 and 5. And then we're going to multiply that by 2 because we want it to go either side. And then we're going to chuck all of that in brackets just so that it gets done first. And then we're going to take away this dot spread. And what we're going to do is just log out the spread amount to make sure that we're doing the right thing. And also to show you this. Every single browser comes with a development environment part of it. Even if, like, I'm using Chrome right now, but if you're using Firefox or like Edge or any of the other browsers that kind of use Chromium underneath, they usually have one of these. So we've got our console here, and we're going to look in this info log for these spread amount values, and we should get 4 of them, 1 for every thing. So there we go. We got 0.34, we got minus 0.34, we got 1.47, and we got 0.69. And if we play it again, we got 1.3, 0.4, minus 4.87, and 3.92. So every time we start and stop, we get a new spread amount. And the cool thing is that we can then use that to calculate a new speed from our base speed. So for example, like we'll call this actual speed to be, again, very verbose about it. So our actual speed will default to 0 because we're going to apply it in start. And our actual speed is just going to be this base speed plus the spread amount. So if it's negative, it will make the speed slower. If it's positive, it'll make the speed quicker. And the only other change we need to make is this should be actual speed. And again, you can see the IDE is helping me type that in without having to remember and type everything and make typos. So what does that do if we save? Well, we press play. You can see each of the turtles is now moving at a different speed. And this time the basic turtle won and the speedy turtle came last. If we play it again, we can see the pink turtle is probably going to win. And this one is maybe second. It's a bit of a photo finish, really. But every time this runs, the speedy turtle, I think, is going to win this. It's kind of neck and neck there. Yeah, so that's like really, really straightforward. But we've already made the game significantly more interesting. And we've only done this with one script, right? Like this is really simple. And I get that this is not really a game, right? Like this is purely to show you how quick scripting is. And we're doing this all of this in the browser, and it's just instantaneous, right? Like I can fiddle with the values and change things, and these guys have all got the same spread and value right now. So the next thing to do is to change these. So like this guy's the fastest turtle, so maybe he really does go 50. But he has a spread of 15, so sometimes he's really slow. And this one was slow, but he's consistently slow. This one's 42, but has a bit more of a spread. And this one, what do we have? Like 40, it was ever so slightly slower. And then is like super consistent at 40. So now is our game more or less interesting? I would say more interesting, because essentially before all of the values were the same. So they were going the same base speed and they had the same spread. So they have an even chance really of being the one that wins. And now it's kind of, you know, totally not random, because it was already random, but there's more character to each thing. So that time the pink one won, this time the red one will win. Consistently slow person's consistently slow. Every so often the consistently slow guy should still win. He's 30, so you could be a max of 35, whereas this one is 42, so you could have a minimum of 32. This one would always beat this one, essentially, is the only balancing issue that we might have. And this one would draw level with this guy. But, you know, it becomes, in a way, harder to predict. And we could take that further. So right now we're just using math.random, but you can improve it. So math.random, we've got a number between 0 and 1. And math.random is just going to randomly generate numbers. And in terms of like a profile, it's going to be flat between 0 and 1. There's an equal chance of getting 0 and an equal chance of getting 1 and an equal chance of getting any number in between. If we do math.random plus math.random, so we get a random number between 0 and 2, divide it by 2 to average it, what we'd get then is a graph that looks like this. Because we've got the two numbers and we're averaging it, you're more likely to end up in the middle than you are at either end. Similarly, if you've got three numbers, you start, or even more numbers, you start developing this kind of distribution. So we could do that as an example, just using that sort of random property. And maybe we should. So if we say everybody starts off with 3 rolls, and this basically then, or consistency, that's an interesting way of calling it. Although it's kind of backwards, so rolls is probably just more obvious. So we've got the number of rolls, and what we'll do is we'll make a for loop like this. And what we can actually do is then have the random number, random equals 0. And we'll cut this out. We'll have the random number, this added together. And then at the end, we'll do the random number divide equals. This is going to divide our number by what's on this side and set it in here by the number of rolls. And then we can use the random number. And we could, if we wanted to look at it, log it out, but we'd have to log out a lot of them to see the actual distribution. We can basically say how consistent they are. So spread lets us define some sense of like randomness to them. So like if we say that this person only has 1 roll, and we should maybe define a number range on this, because 0 is a bad number to have. A 1 to, I don't know, 5, because we don't really need that many. And we can just set this with this. So this guy can be more consistent. This can be a bit spikier. And this can be, again, linear. And so that means that these guys with 3 or with 2 will always be usually closer to the base speed than the others. So the others are a bit more like, wee. Tell us about that for loop. Okay, sorry. Yes, I'm skipping ahead. I want to run through this loop a set number of times. So in this case, you need to define 3 things, or you can define 3 things, I should say. So this first one is the initial conditions. So before the loop has started, I'm creating a variable called I, and I'm initializing it to the value of 0. The second one is the condition to evaluate the loop. So I'm going to run this loop whilst I is less than the number of rolls to do. And so when I get to the end of the loop, this is what's going to happen. And plus plus I means I'm going to increase the value of I by 1. So it's going to, for every single loop it goes through, I is going to increase by 1. So it'll go 0, 1, 2, then it will get to 3. It'll check this condition, and 3 is larger than rolls if it is 3. And so we'll end the loop. And that lets me do this. Every single loop, I want to add a new random number into my random number, and then I'm going to do the average of that afterwards. But yeah, so we've got the spread worked out. But what does that do for our game? Well, let's just save what we've got. Control S. And so we can see the red guy charged ahead. We're getting incremental gains to the game now. Like, this isn't really changing a lot about the result that we can see. But it is changing some things, like the red guy is zooping away. And so we can kind of see that maybe having the wild spread. So that is basically just like, as far as I really wanted to take this game in terms of it being a game. But the next thing to do is to make this multiplayer. And if I make it multiplayer, and then we can share it into the thing. Ooh, they've legged it. You can see it going whilst I'm in here. And they'll run past the end, obviously. And so I can edit it and stop. And then what I'm going to do is paste this URL into chat. The thing is, if you joined right now and other people could see your screens, what you'd find is that everybody's turtle positions are different and they're initializing to different values. And that's kind of, lame because we're in the shared environment. And like, I wonder if Chris is actually genuinely sat on that turtle or not. Something has gone horrifically wrong. Is this just my computer stalling out? No. Which one's in the lead for you, Chris? Right now, who's winning? The red guy. Well, that is, yeah, always going to be the red guy. Let's see. Where's the pink one? Run and jump on the pink one for me. Is that the pink one you're on? Okay, yeah. So you are seeing them roughly in the right place, which is interesting. So yeah, we'll go into the game and I'll show you what we need to do to make these actually networked. And the reason why I wouldn't expect that is right now, start is being called for all of them. And this random value is going to be different on everybody's computer. So probably what we've done is made the result deterministic enough that it just happens to work. And you kind of could see Chris get snapped a little bit onto the turtle's position. All of his stuff is being networked to me. So when he jumps on a turtle, he gets put onto that turtle, even if that turtle's in a different position on my computer. So I see him where he is relative to what he's standing on, which is kind of why it's hard to tell what's going on, which is one of the fun things about making multiplayer games. But yeah, so all this code is being run independently on Chris's computer and on my computer. And so what I want to do is make it so the code is only run on my computer, because I'm the person that started this game. I am in charge of it, and all of the entities that are in this game and are part of networking, I want control over. So I'm going to put a check at the top here for, is this entity owned locally? And if it's not owned locally, I'm going to stop running this function. And I'm going to do the same thing in tick as well. So this lets you decide, based on who owns an entity, what code will be run on everybody's computer. So now this code, if Chris will have to reload to get the change, because right now this isn't networked. Again, one of the things that we'll be fixing shortly. Now this code will only run on my computer. Well, will it? No, it won't. Because right now, these turtles are not taking part in networking. They're just entities in the game, so everybody owns them. You don't need to worry about this sort of thing, because this code will run anyway. Because if an entity, so okay, we can mouse over it and see what the docs say. Returns true if the entity is networked, and if the local peer owns it, and it returns false otherwise. So what we're saying is that we need these to be taking part in networking for this check to make any sense. Now, if I select all the turtles and I add the net tag to them, so now they will have the net tag, and I save that. And this means that they will now take part in networking. And it does two things as well. To take part in networking, you send messages backwards and forwards between every computer that's connected. And we want to send their position across. We're in charge of how it's moving. So we just want to network their position. But the good news is just sticking the net tag on there means Stop Big Bang will do that for us. And what I'm going to do is, just to make sure everything is working, I'm going to reload the game in. So we're in a perfectly, everything is set up and understood by the system state. And the reason I'm doing that is purely for abundance of caution. And also because I believe after you've added the network tag, the net tag to an entity, you'll have to reload the game in order for the engine to know that. Again, one of the rough edges and why this scripting is early access right now. I'm going to share the game again, create a new session, and then edit it and stop it and copy it across into chat. And we can see what's going on with turtles. So now these turtles' position is being driven by my thing. Jump on the, yeah, that one. Yep, Chris is on the pink one. And you can kind of see that he did go much more directly towards that. And if we stop and play again, jump on the two turtles. Okay, John, double turtles. Chris is jumping on the red turtle because he's not listening. Yay. And yeah, you can see him jumping between the pink and the double turtle there. And they'll run off the edge of this world and go on for infinity because there's no gravity being applied to them or anything like that. And that is as easy as it is to make something networked in this fashion. And so there's really not that much to it if you want to make something quite basic. But what else might we want to do from this? So our turtles are quite boring right now because they don't have names. What we actually need is a text renderer component on our turtles. And annoyingly, we can't do that just yet without cheating. So we're going to cheat ever so slightly. And you can see this understands it. I'm going to add a text renderer on there. If you want access to this, as I say, just come into our Discord and ask about it in scripting if you need it. I'm going to use the, which one? Monroe. I can't remember what they look like. So they all have that, and they all have text saying hello right now. And we can do a bunch of stuff about alignment. Center sounds good. We can see it now, and it needs to be offset up, so above their head, and be made bigger. It needs to be wider as well. So now we can give each turtle their own name, and we'll have names as a string. And I'm going to be daring and do multi-line and see if it works. It wants true. Yes. So we have multi-line text boxes, which I've never used, which is exciting. So let's start putting some names in. Cheeto and Snail and Bertle and Bingo and Pingo and Turt Reynolds. Does anybody else have any suggestions? So we have loads of turtle names. Now we want to, when the game starts, call our turtle by a new name. What we're going to do is, before we work out how fast we're going to go, we're going to get all of the names out. And we're going to do that by going this dot names dot, can we split? So this is going to take a separator. And in this case, I'm going to use the new line separator and give us an array of strings. And I hope I get this right the first time. So this is what the new line separator looks like. It just basically means the character that you get when you press enter. And it's a bit of a programmery common thing, essentially. So we've got all the names, and then we're going to get our name is going to be, we need to get something from names. And it's an array, so we need to access the array, and then we're going to say what element number we want to access. So it's a number between 0 and however long the array is. And that's going to be math.random, which is a number between 0 and 1, multiplied by names.length, which is between now 0 and the length of the array. But that could be a fractional number. It could be like 1.135. So what we want to do is floor that number. And what that means is if it is a number like 1.3, it's going to go to the closest number, round number, closest like whole number, like 1, 2, 3, 4, 5. Going to go to the closest whole number below that value. So if it's like 1.9, it's still going to go to 1. And that means that if we're nearly at names.length, so if it's 10, then we'll always go to 9. And that means that we'll access the right index, because arrays in programming languages are usually 0 index. So the first thing is at 0, the second thing is at 1, and so on until the end of the array. So it could have a length of 10, but if it has a length of 10, the last element will be 9. So we've got a name out, or at least hopefully have a name out. Let's just check. Let's just check that that's doing the right thing. So we're going to log out our name and do this. This is string concatenation. I'm taking the string name and I'm adding on the name that came out of this, which should also be a string, which will be handy. So we're going to play. I don't know if Chris is still in here or not, but he won't have any of these changes. So we got name undefined, name C, name undefined. That wasn't a good start because we're not getting any of the things out that we want. So we're going to need to debug this. And to do that, we need to find our scripts. Okay? And they happen to live in this game frame. Twitch tutorial move forwards and backwards. And we can see we have our entire script here in Chrome DevTools. And we can go and click here and set a breakpoint. And a breakpoint is a position that we will stop at when the game is running, and we'll be able to see what's going on. Yeah, programming is really fun. It's a lot of scientific things. So we have all of this nonsense down the side here, which is quite useful for a variety of things, but we're going to get rid of all of these. And first of all, we're going to see what this .names actually has in it. It is an empty string, which in itself is worrying because that is not what we want. So if we press play, okay, here we go. We've actually got one that has all of the names in it. And you can see my mistake immediately. I've got /n there. And this one has \n as the separator. So, you know, just so you know that sometimes you really do need to look things up in order to do it. And if I type in names, it's an array of length 1, which has everybody's name in it. So really, it's not doing a good job of breaking that array apart. But we found out what the problem is really quickly. So we can continue playing the thing, stop it, change our front slash to a backslash if I can figure out where on my keyboard the backslash lives. And then hopefully this time when we run, we will see some names be populated. No. Oh, so what we've done, stupidly, is we're getting a random value from names.length, which is 12, but from this .names as the array, which is just our long list of things. So we're accessing the wrong array to find out the names. So again, silly mistake, easy to make, easy to spot and diagnose. And this is why the debugger is so helpful, because you wouldn't be able to tell that necessarily without logging out a whole bunch more information. And we did it nice and quickly. So now We'll definitely get a name out when we press play. Shelly. Bingo. Cheeto. Bingo. Snail. Okay, that's working for everybody. So we're like 90% of the way to making our feature work with no networking in it. This will only happen on the server and nobody else will be able to see it. We need to copy paste this essentially to all the others because we stupidly did not set them all at once. And we could actually define this as well by default in here if we wanted to have those names be shared. And, you know, because we've shared the same list with every single character, they could have name clashes. But, you know, in the real world, you have name clashes as well. There are loads of Charleses out there, a few Chris's, and so on. And so now when we press play and we stop the game, we can go back in and see we've got Turt Reynolds, Snail, Turt Reynolds showing that clash off immediately. That's handy. And Digital Monkey Master. Okay, so we have names generated. What we need to do now is set them in our text renderer. We'll get our text renderer. I'm going to get that from our entity because that component is on our entity. So we're going to get component by type, and our component type is text. And so let's just call this text. And then if we go over the value of text, it can be a text component or null. And what does null mean? That's kind of confusing. We want a text component, but we got a text component on null. And that's because the entity might not have a text component on it. And the way that we can say a text component isn't there to the person that's asking for one is to pass back the null value, which basically means nothing, not there, and so on. So we want to check that the text component doesn't equal null, which is a nice, easy thing to do, like that. And if it doesn't, then what we want to do is generate our name, because otherwise we're doing work that we didn't have to do. So we can copy and paste that in there now and line it up. So we've got our name, we've got our text component, and inside here, the other cool thing to note is that inside here, this text out here is a text component or null, but TypeScript understands that we've checked that it's not null in here. So inside here, text component, text is just a text component. Really useful to check by hovering over things what the compiler thinks is going on. So we've got a text component, and I believe it's annoyingly called text, and we want to assign that to be name. Job done. Is it? Let's see. And we press play. And we can see that apart from not having enough space in our text component, that has actually done the right thing. So let's get our text renderer and increase the width slightly and left align it so it's over the top of everybody. So Michelangelo still got a little bit screwed over. Oh, it's because I don't have him selected. Come here, Michelangelo. And we get the text component, left align it, and make it bigger. So now they all have their own name. But what will happen is they won't share a name across the network. And I'm going to try and prove that this time. So we save the game. I'm going to copy this. I'm going to create a new window. And we're joining the same game that I'm in over here, in here, which is cool. And the game is not running. And if I start it and then pause it. So the green one is called Michelangelo. Red one's Turt Reynolds. Pink one's Bingo. Double one is Cheeto. And if I go across to the other game and I go into the edit mode, because we're in the multiplayer game together, they are named the same. How are they named the same? I don't understand. So Pingo, Leonardo, Snail, and Donatello. I'm going to be really sad if... Okay, now this time they're all called hello, 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 hello. So what was going on there? When I joined the game, the values of the properties that are public of the components were shared from the server. So everybody had the same name. But when I stopped and started the game again, I wasn't joining and I wasn't getting extra information. I was already part of the game. So they just have the values that they had before. So we want to network this name so that I get that information on both sides. Where we've set the name here, we're going to get this.game, so the game that we're in, the session that we're in, the multiplayer session that we're in, and we're going to send a message. And this has a long amount of information, but the basics of it are when we send a message, it is broadcast to everybody else that's connected to the game, and they'll be able to receive the message and then do stuff with the information that we send them. And so you can send it to any entity, but for us, the majority of the time, we always send network messages to the entity that we're sending it from, just to help you structure in your brain what's going on. If you're big brained, then you can send it to any entity you like, and that can be useful for some things. So we're going to send a message, and we're going to send the turtle name type as our type of message, and then we're going to pass across the name. And that's all we need to do to send a message. That message is going to go to everybody in the network, but right now nobody's going to pick it up. So how do we do that? Well, we need to define a new script callback called onMessage, and it takes in the name of the message as a string, some data, which we're going to use any for, and then a third thing, which is actually the sender who sent that message to us. Oops, I've done that wrong. You can see how much time I spend doing other programming languages. This has a bunch of information, but it's optional. You don't need this on there. So we're not going to use it because we don't need it. So the first thing, when do we want to run this? Well, we don't need to run it on the server because we can basically ignore any message anybody else sends us to this entity. We don't care. So if we are locally owned, then we're going to run away. And since anybody could send any message to us, we want to make sure that we're not just using any old message turtle name. So if the message is not turtle name, we're also going to run away. Now we know that we have our turtle. We can do a little bit of copy and paste. Grab this from up here. So now we know we have the right message in the right place on the people that don't own our turtles. And so we're going to get the text component out. We don't need to do this because we already have the name, and that is in the data. It's just data.name because we put in name in this little object up here. And we don't need to send a message because we're just getting that information through. So we're going to get a message with the turtle's name in it, and it's all magically going to work, we hope. So Shelly, Raphael, Digital Monkey Master, and another Raphael. And on this side, we have Shelly, Raphael, Digital Monkey Master, and Raphael. And just to prove that was working, we'll do the case that didn't work last time, which is to stop and start again. And if we go back onto this side, we have a Leonardo, Digital Monkey Master, Snail, and Turt Reynolds. So it is working correctly. We have networked the name from the server to all the people that are connected, and hopefully Digital Monkey Master can also see the same names. And yeah, I hope this has actually been helpful to people getting started. Thank you. Goodbye.